Hey everybody, this is 9.4, number 10, and we are supposed to graph a piecewise function and then talk about where it's not differentiable, and to graph it, we're going to just use our graphing calculator, or if you remember anything from college algebra, we can probably pick out the answer from there. Okay, so if I want to just talk about maybe what this picture looks like, this piecewise function says f of x equals negative 3x if x is less than negative 1. So the way I'm going to use my calculator to help me out is I'm going to, in the y equals, type in negative 3x, and then I'm going to look for the t-chart for when x is less than 1, so 1 and everything underneath it, so like the x value of 1, and then what numbers are smaller than 1, like 0, and then we go into the negatives. So this is for x less than 1. Okay, then I'm gonna use my calculator to graph this other equation that says f of x equals, the bottom sucker says negative 3. So in my calculator, I'm gonna type y, in my y equals, I'm just gonna type negative 3. Then I'm gonna go look at my t-chart, and for this second part of the piecewise function, it says x bigger than or equal to 1. So the numbers bigger than or equal to 1 are 1, 2, 3, 4. Okay, so let's use our calculator. Okay, I'm gonna pick it up, go to y equals, type in negative 3x, and remember, for that negative 3, you gotta press this white negative, not this gray one on the side, the one at the very bottom. So negative 3x, then I wanna go to my t-chart, so second graph, and then I'm gonna write down the y values across from these x values that are less than 1. So across from 1, I see negative 3. Across from 0, 0. Across from negative 1, 3. Across from negative 2, 6. Okay. Then I'm gonna draw these points on my graph. Okay, the only thing is, at the very beginning of this question, it said negative 3x if x is less than 1. That means that when x is 1, because of that alligator, since it does not have the little tick mark underneath, that means for this first equation, when x is 1, we use an open hole, because that alligator does not have an equal tick mark underneath it. So that means for this negative 3x equation, when x is 1, I'm going to use an open hole. And then vice versa for the other piece. This second equation, when f of x was equal to negative 3, it said x bigger than or equal to 1. And because of that equal to, that means when x is 1, we're going to use a closed hole. And that's because we had that greater than or equal to. And if we would have had a less than or equal to, we still would have used a closed hole. Okay, so that means for this second equation, when y is equal to negative 3, we're going to use a closed hole for whatever this y value is. Okay, we're just not ready yet. Okay, so let's go back to graphing this pink stuff, this y equals negative 3x. We're going to have 1, negative 3, and that's an open hole. Right 1, down 3, and that's an open hole. Then we're going to have 0, 0, bam. Negative 1, 3, left 1, up 3, bam. Negative 2, up 6, bam. So every dot that I draw is normal, except for at this 1, negative 3, it's an open hole. And then let's connect these. Yeah, okay. And I'm not going to look at the part of the t-chart when the x value is bigger than 1 because this alligator says x less than 1. So we can only use the x values that are smaller than 1 in this t-chart. Okay, if I look at this other sucker, it was y equals just -3. So let me type that in, y equals -3. And then go to your graph. And I'm gonna write down what's across from this 1, 2, 3, 4, because those are the numbers that are bigger than or equal to 1, which is this second equation. It's at -3 is if x is bigger than or equal to 1. So I'm going to use the x values that are bigger than or equal to 1. Okay, so across from the 2, I see -3. Across from the 3, -3. Across from the 4, -3. Okay, so let's draw these. Oh, my bad, I forgot. Across from the 1, -3. Okay, so at 1, -3, we're going to have a closed hole. So to the right 1, down 3, and that gives you, to the right 1, down 3 is a closed hole. So even though this pink had an open hole, this closed hole that I just drew, it fills in that open hole. So even though for this y equals -3x, at 1, -3, we were supposed to have an open hole because the alligator did not have a tick mark. When I draw this closed point at 1, -3, it fills in that open one like a pothole. And then I have 2, -3, 3, -3, 4, -3. Okay, let me draw that. To the right 2, down 3. To the right 3, down 3. To the right 4, down 3. And then I'm gonna connect those beasts. Okay, now what I'm gonna do is I'm gonna pick the correct picture. So the correct picture for this one is whatever comes down and then straight across, but we have a closed hole here because it's kind of like this closed hole fills in this pothole from the open hole. So the closed fills in that open hole or that pothole. So either way, we're just supposed to have 2 pieces of line with a closed hole. So for us, we're gonna be, these 2 suckers are wrong because it looks like it's going the wrong direction. A and D look right because they're kind of going the correct direction. They come down, then they go across. The only difference is between A and D, the hole. Well, remember, the closed hole fills in the pothole. So A is wrong because it still has a little pothole. D is right because it has that closed hole. Okay, then the question says, where is the function non-differentiable? That means where was the open hole before it got filled in? So where was the open hole before it got filled in by that closed hole? So let's look for the open. It was right here at 1, -3 before it got filled in. At 1, -3. So since it was at 1, -3, the answer choice is asking for the x value, and this 1, -3 is like xy. So in the answer box, I'm going to put when x is 1. So it's not differentiable. That means I can't find the derivative or the slope or anything right there when x equals 1, because that's what had the open hole. And remember, it had an open hole because the alligator was normal. It did not have that equal tick mark underneath.